Hello, I'm Professor John Kelly, and this is the Weber Auto YouTube channel. In this series of videos, we are going to be looking at the Chevrolet Volt. The Chevrolet Volt is a series hybrid. General Motors calls it an extended range electric vehicle, and we will learn what that means and what the difference is between that and, say, other hybrids on the market, parallel hybrids and series parallel hybrids. But the Chevrolet Volt is the #1 selling plug-in hybrid vehicle on the market. And I believe the reason for that is it has the longest electric-only vehicle driving range. The second generation Volt that I have here, 2018, that came out in the 2016 model year, has a 53-mile electric vehicle range on average over the year. It would be worse in cold weather, a little bit worse in the hot weather. The first generation Volt that came out in 2011 had a 35-mile range, and then a 38-mile range in 2014, and then a 53-mile range in 2016. I have actually owned two of these. I have a 2014 model myself, and my wife drives it, and we just really like it. It's a fantastic vehicle, and we're going to be looking at all of the high voltage systems on this vehicle that make it unique. But we are also going to be looking at things that are common between almost all plug-in hybrid electric vehicles and many electric vehicles. All have the same components. They might be a little bigger or smaller or have a different name or located in a different position on the vehicle, but there are a lot of similarities. And so if you can understand the Chevrolet Volt, you can understand most plug-in hybrids on the market and most electric vehicles on the market as well. So in this first episode, we are going to be looking at the high voltage battery system. I've removed the high voltage battery out of this vehicle. It's a 355.2 volt lithium ion battery, and I have it out of the vehicle over here, and we're going to take a look at it. We will also, in future episodes, look at the 5ET50 transaxle and what's different between it and the first generation 4ET50 transaxle, the improvements that were made. We're actually going to remove it from this car and take it apart and put it back together and put it back in later. We will also look at the cooling systems on this vehicle. It has 3 different cooling systems. We will look at the air conditioning systems, the heater systems, the auxiliary power module that takes the high voltage and steps it down to the 14 volts that charges the regular 12 volt battery that's still in this vehicle, that everything else on the vehicle runs on, and many other things on this particular 2018 Chevrolet Volt. So let's go take a look at the battery and see what it looks like, what parts are there, what's serviceable, the precautions to keep from electrocuting yourself or others, and what we can do with this battery, diagnostics and so on. So let's go take a look at that. Okay, let's take a look underneath the Chevrolet Volt and take a look at the battery. As we start from the back here and move forward, we can see this big T-shaped black metal housing. That is the bottom of the high voltage battery. And it's quite long, comes all the way up here to the steering rack on the cross member. Then we've got our transaxle, engine, cooling system, and so on. Let me turn around, we'll go back the other way and look. Looking right up here at the front of the battery, we can see 2 cooling pipes connecting in. The great big orange electrical connector up there for the DC current going in and out of the battery, and then 3 smaller orange electrical connectors for, well, let's see, one's for the cabin coolant heater to add heat when you're in the cold weather. We've got one for the air conditioning system compressor, the electric AC compressor, and another one for the auxiliary power module in the trunk area, and also the charger. The plug-in charger shares that same electrical circuit there. So as we come to the back of the vehicle here, you can see the T-shape housing again, and then Under the very back here, you can see the two cooling pipes that cool the auxiliary power module that converts the 355.2 volts down to 14 volts. It also sends coolant to the plug-in charger inverter, where it takes the AC voltage from the plug-in charger and inverts it and smooths it back out to a DC and feeds it back to the battery, the high voltage battery in this vehicle, to charge the battery, of course. So both of those are liquid cooled. So I worked with a couple of my students to remove this high voltage battery. We went through the disabling procedure where we removed the key fob, we unplugged the 12 volt battery, we make sure at the transaxle that there is no high voltage at the electrical connector from the high voltage battery to the inverter on top of the transaxle, and then we unplug the electrical connectors at the front of the battery. We disconnect the cooling pipes and drain the coolant, and have this special holding fixture up underneath to support the battery from twisting or flexing as we take it out. Otherwise we could break some of the cooling plate passages, the plastic ones, with the battery tray flexing. And then, as you can see here in this video, we slowly lowered the battery down to where we can work on it. And then we took the cover off, as you can see here, and then we've got the battery exposed just as you can see here. Okay, now with the battery removed, let's go look underneath the vehicle and look at where it came from. You can see this big T-shaped opening in the bottom of the vehicle, and there is a hole right up there that is underneath your center console area. That is where this service plug is accessed. So when the service plug is removed, it open circuits the battery system inside the battery housing, which makes it a little safer to work on. It's not totally safe, because all it does is split the battery into two sections rather than one section, and there's still high voltage there, but it makes it a little safer to work on. Off to the driver's side here, there's a whole bunch of pipes. The two pipes on the far left-hand side are the coolant pipes that go back to our accessory power module or DC to DC converter and our plug-in charge inverter. The great big pipe on the right here is our high voltage cables, and then we have the two black pipes are the right and left rear brake hydraulic lines, and then the two other pipes there in the middle, the stainless steel ones, are the fuel pump feed line for the fuel injectors, and then the vapor recovery line also. So we've got, what is that, 2, 4, 6, 7 pipes running from the rear of the vehicle to the front. As we move forward here in the tunnel where the battery comes out of, you can see a structural support area here in the middle. That gives the vehicle some additional strength during a side impact collision. Your very first Chevrolet Volts 2011 and some of the 12s did not have that, and there was either a service recall or a service campaign to remove the battery and install one of those to give it some more strength. And then up front here, these are the electrical and coolant connections to the high voltage battery. Now you can see the two coolant pipes right there. The one on the right is the inlet, the one on the left is the outlet, and then the big electrical connector with the blue insert, that is our high voltage current in and out. It's just two wires that go from the battery up to the inverter assembly on top of the transaxle. And then we have three smaller electrical connections there. We've got the electric air conditioning compressor, the cabin coolant heater, and then the third one over here is our accessory power module and plug-in charger connection. Then we have two low voltage connections, these black wires here. That gray connection right there is that gray connection right there, and that black connector right there are the low voltage connections between the hybrid powertrain control module number 2, which is under the driver's seat, and the battery energy control module, which is on top of the battery. Most of those are data communication lines, but there's power, ground, ignition wake up, ignition switch, controls for other external components as well, and we'll take a look at those in more detail a little bit later. Okay, well, let's go take a look at the removed battery now. As I go around the battery, you can see the orange high voltage connections. You can see the battery modules. There's 3 battery modules here that we'll take a look at. You can see the high voltage positive and negative battery cables, the voltage sensing cables, temperature sensors, the battery energy control module, the computer that watches all of that on the top here, the service plug, the contactors, battery heater, and so on. And I've taken all of that apart, and we're going to start with an empty battery tray. So as you can see now, I've taken all of that apart, and we have a completely empty battery tray right here. And we are going to, in this video, reassemble the entire battery and get it ready to put back in the vehicle. Alright, as I've mentioned, this battery is liquid cooled, and there's an interesting hole in the battery tray that I want to point out to you. When we take the battery totally apart, get these braces out of here, right in the front, right here, is an inspection hole. And there's just a plug that bolts in from underneath there with some sealant on it. And when you first go to remove a battery out of the vehicle, they tell you to pull that plug out and see if any liquid comes out, or if any metal flakes come out, or anything comes out of there. And I wasn't quite sure why they had us do that to begin with, but then after I disassembled the battery and figured out how it worked and its cooling system and all of that, I realized that this entire bottom pan here is sealed, and so if there's a coolant leak anywhere in the battery, it's going to accumulate here in this front pan here and build up enough eventually that when you pull that plug out, if coolant comes out, that's a sign to you, without having to disassemble the battery or take it out of the vehicle, that there's a coolant leak inside the battery and that the battery does need service. If you pull that plug out and nothing comes out of there, then you can be pretty sure that there is no cooling leak internally in the battery. So that's the inspection plug there. All right, we will come back to these braces and brackets that help hold things in place. But for now, let's go take a look at the rest of the components that go with this T-shaped battery tray up underneath the vehicle. With the high voltage battery removed from the vehicle and the cover removed from the battery and high voltage terminals exposed, you must protect yourself with personal protective equipment, and you must protect others from accidentally touching the wrong thing and getting shocked or even killed. And so the entire time that I've had the battery out of the 2018 Volt, whenever I'm not around the battery to supervise it, I keep it on a table inside of these 4 cones with hazardous area or caution tape or something to warn people, along with some high voltage signs, that they should stay away. And of course, everybody that comes up to the battery, the first reaction is to want to touch it. And so this will help warn them to stay away from the battery itself. So let's look at the battery now. Okay, the battery comes in 3 sections. And so here on this table, I have all 3 battery sections removed from the battery tray. This front piece right here with the green cap on it is section number 1, and then of course section number 2 right behind it, and then forming the T-shape portion of the battery is section number 3. Each section is made up of individual modules. This is battery module number 1, and then battery module 2, battery module 3. So battery section 3 is made up of 3 battery modules, and then battery section 2 is made up of 2 more battery modules, and then battery section number 1 is made up of 2 more battery modules, making 7 battery modules in all. Now, each battery module is made up of individual cell groups. So if you look closely at the battery here, you can see these little lines, vertical lines. Each of those is a cell group. And going across here, there are 24 cells. So battery module 7 has 12 cell groups. Battery module 6 has 12 cell groups, for a total of 24 cell groups at 3.7 volts each, which gives us 88.8 volts nominal voltage for this first battery section. And you'll notice that each battery module has 2.3 kilowatt hour rating, and then that's for each cell or battery module. And then of course the 2 battery modules combined gives us 4.6 kilowatt hour rating for this first battery section. All right. If we look at battery section number 2, we have 28 cell groups. So battery module 4 has 12 cell groups in it, just like battery modules 6 and 7 did, but then there are 16 cell groups in battery module 5 that gives battery module 5 a 3.1 kilowatt hour rating. Battery module 4 still has 2.3, just like the first 2 that we looked at in modules 6 and 7, and that gives this battery section a total kilowatt hour rating of 5.4. And then this very back section here, battery section 3, has 3 battery modules with a total of 44 cell groups. And so the cell group here in the middle, notice, is rated at 2.3 kilowatt hours, and that is made up of 12 cell groups, just like the first 2 battery modules in battery section number 3 at 2.3 kilowatt hours. But then you'll notice battery modules 3 and battery module 1 each have 16 cell groups in them for 3.1 kilowatt hours apiece, which gives us a total on this rear battery section number 3 of 8.4 kilowatt hours. All right, I know that's confusing, but we have 3 battery sections: the rear section, the middle section, and the front section, numbered 1, 2, and 3 from the front of the battery to the rear of the battery. Each section is made up of individual battery modules, of which there are 7 total, We have battery modules 1, 2, and 3 in this rear section number 3. We have battery modules 4 and 5 in this center section, and battery modules 6 and 7 in the front section. And then each battery module is made up of cell groups, of which we have 24 cell groups in the front battery section, section 1, 28 cell groups in the section 2, the middle section of the battery, and then 44 more cell groups in this rear section for a total of 96 cell groups. Now, each individual cell group is numbered, and the numbering begins back here in this left rear corner. So if I lift up the protective cover here, the high voltage cover to keep people from touching the wrong things, here in battery module 1, you can see that we have cell groups 1 through 16. And so cell group number 1 is right here on this end, then number 2, 3, 4, 5, 6, all the way through 16. Battery module 2 has cell groups 17 through 28. Battery module 3 has cell groups 29 through 44. Now you may be wondering, why do we need to know which cell is which? Who cares which cell is which? We need to know that because each individual cell group can have its own unique diagnostic trouble codes. So each cell group can have multiple trouble codes. And of course, since there's 96 cell groups and these trouble codes are per cell group, we have a whole bunch of diagnostic trouble codes that can be set. Luckily, these have been very reliable and we haven't had many problems with them. So in the back battery section here, cell groups 1 through 44. We can see that battery module 4 has cell groups 45 through 56, and battery module number 5 has cell groups 57 through 72. Battery module 6 has cell groups 73 through 84, and battery module 7 has cell groups 85 through 96. Now, let's look at what a cell group means. Okay, to understand what a cell group is, because we have 96 of them here in this 2018 Chevrolet Volt, we have 96 cell groups. A cell group is 2 or more lithium-ion battery cells that are welded in parallel with each other. Now, the first generation Chevrolet Volt, of which I've got a battery section here from a first generation Chevrolet Volt, the first generation Chevrolet Volt had 3 3.7 volt lithium-ion cells welded together in parallel. So let me show you a lithium-ion battery cell from a Chevrolet Volt. We're looking at one right here. This silver plate right here is another one right here. I've actually cut this one out of the battery. And this is one 3.7 volt. It is not dangerous voltage, but when you put them all in series, they add up. This is one 3.7 volt lithium-ion battery cell. Now, it's not a cell group unless we put 2 or 3 of these together and weld all of their positive terminals together and their negative terminals together. So on the first generation Chevrolet Volt, there were 3 of these plates welded together, positive plates, negative plates welded together to make a cell group. So a cell group gives you additional capacity without increasing the voltage. So each one of these battery cells, to give you an idea of how much power they have, can provide roughly 55.5 amp hours of electrical power. Theoretically, that means 55.5 amps for an hour. Or, cut that in half, 27.75 amps for 2 hours, and so on. But if you put 2 of them in parallel, you double that. If you put 3 of them in parallel, you triple that. So on the first generation Chevrolet Volt, they put 3 of these in parallel with each other. Apparently the battery chemistry was different back then than it is on the second generation Volt. It wasn't as powerful, because on the second generation Volt, which is a more powerful battery, 18.1 kilowatt hours versus 16 kilowatt hours on the first generation Volt, on the second generation Volt we only have 2 of these in parallel with each other, and it's more powerful. So this is a lithium-ion battery cell. You weld them together, the positive and negative plates, and you get a cell group. Now, this is a liquid-cooled battery. As you can see right here, we have a coolant inlet and a coolant outlet. The coolant comes in, it goes through the battery in between these plates here. These are all sealed. There's no liquid going through these. But there is what's called a coolant plate. This is a coolant plate. It's actually very pretty. But if you look real close, right here on the end, it's extremely hard to see. There's all these little tiny coolant passages that come in and follow these passages up and around and back out. So this is the inlet, then it comes through, up and around. The heat is transferred from the battery cells into the plate, because the plate is sandwiched in between the cells, and then the coolant comes out on the outlet side and leaves the battery. So on a cell group, we can have 2 or 3 plates welded together in parallel with a coolant plate in between them to get the heat out. Now, from what I can see here on this first generation Volt battery, there's only 1 coolant plate for the 3 battery cells, and so it only goes in between 2 of the 3 cells, as far as I can tell. I could be wrong, and if any of you know if I'm wrong, please let me know, but I cannot see another coolant plate in between the second and third cell. So on the second generation Volt, there's 1 plate in between every cell, and so I think the cooling would be a little more efficient on the newer second generation Volt batteries. But this is just going to sit in here just like that, and then this whole piece, I've opened it kind of like a door, would flip back around and rest right against that other cell and allow the heat transfer to take place. So that is a cell group. So this liquid-cooled battery has 96 cell groups. Depending on whether it's first generation or second generation, you might have 3 lithium-ion battery cells in parallel or 2 in parallel. All right. Now, we are ready to take these battery sections and put them back on the battery tray over here. So we've got this empty battery tray. We need to put the battery sections back on it. But these battery sections are pretty heavy, and they're very sensitive to twisting, and it's not something you just want to go pick up yourself. Well, and they're high voltage. This front section is 88.8 volts, the middle section is 103.6 volts, and this back section is 162.8 volts. And you'll notice up to this point I don't have any high voltage gloves on, but now that we're going to start moving things around and making electrical connections and so on, I need to get on my personal protective equipment. This battery right here, it's the maximum. This battery section is 22.2 volts. It's not a dangerous system voltage-wise to be working on. But let's move on now to installing these battery sections back on the battery tray. Okay, to lift this rear battery section, section number 3, back to the battery tray, there's a special lifting fixture, lifting adapter that hooks onto a regular engine lifting hoist to lift it up, and then we can set it down on the tray and get it bolted down in place. So let me bring that over. All right, as you can see right here, I have a battery lifting adapter, and this has these little arms that we loosen up. It spreads out, comes in, spreads out, and it's going to come in and hook under these edges right here. It looks like it's not going to let me lift it with the high voltage protection covers in place, and so I'll have to get my gloves on, and we'll take those covers off and lift it that way. The high voltage lineman gloves that I bought back in June are near their expiration date. They are good for 6 months. And these are class 0 gloves, rated for 1000 volts. These are marked as low voltage because in the non-automotive world, voltages less than 1000 volts are considered low voltages. There's much higher voltages out there than what we're working on in automobiles, but in automobiles, anything higher than 60 volts is considered high voltage by SAE standards. And so I've got a separate video on personal protective equipment. You can click on the link and see that if you want to get caught up on what tools to use, how to check your gloves for leakage, and when you need to replace them or get them recertified. And we are at the recertification and replacement or replacement portion of the of that time. Okay, now I'm going to take off the high voltage cover here that exposes the positive battery terminal of this big 162.8 volt battery section. Positive terminals here, negative terminals on the opposite end. There are bus bars that connect the 3 battery modules, I keep wanting to say sections, that connect the 3 battery sections together. And we will look at the testing of the individual cells and the voltages and all that once we get it installed back on the battery tray. All right, we want to have this as centered on the battery as possible, and then we just squeeze in and take up the slack in the slots that allow this fixture to come in and lift under the edges of that battery. And then we just got some thumb screws here that we snug up. Do the same thing on the other side. Want to pay close attention to these coolant fittings here on this back battery section, back battery section, to make sure that we are not going to break them. You break that and you're buying an entire battery section. I don't know what the cost is on these, but I'm sure it's a lot. I see used entire batteries on eBay anywhere from $3,000 to $6,000, and I'm sure a new one is more than that. All right, we've got a good hook underneath the battery cell groups there, and let me just double check the other side. Yes, looks like we're clear and ready to lift. So now I'll just lift this up. Let's just give it a quick look over to make sure that it's not coming undone anywhere. Looks good. So now we can move the table out of the way and move the battery tray in. All right, we've got our battery tray positioned somewhat close. Let's bring in our engine lift. Bring it down just a little. Move our tray over a little bit. Somewhat in that range. Looks like we're off just a tiny bit. Looks good on the other side. Looks like we're not centered. We got to get it centered better. All right, we are down. Okay, it looks like I've got it centered this way, and it looks pretty centered left and right. There is not an exact spot that it has to sit. It just needs to be centered the best you can, and then there are hold down plates that will hold it in place. And then of course we have flexible tubing for coolant and flexible wiring for the electrical connectors. So I've got a little bit of gap here on this side. Let me just check the other side and make sure it's good. Tiny bit more gap on this side. I think we're good there. So I'm going to get the hold down straps and bolt it down to the tray next before I disconnect the hoist. Okay, these are the hold down retainers that will bolt down. There's a top and a bottom mark on them. So they're going to come in, set just like that. There's 9 bolts in each one. These bolts will be torqued to 80 inch-pounds. Okay, we can get this lifting fixture off of here now. The battery's not fully bolted down yet, but the lift is in the way for me to finish that, so. So as I said, these bolts will be torqued to 80 inch-pounds, which is just a little bit less than 7 foot-pounds. So they're not very tight. All right, if my memory serves me correctly, and I better look it up, there's a specific tightening sequence for something here. It might be the battery cover I'm thinking of. Here we go. No, there's no sequence on the battery retainers. You just tighten them to 80 inch-pounds. Okay, 80 inch-pounds. Okay, now that we've got battery section 3 installed on the battery tray, I want to take apart some more things and take a little deeper look. And of course, if you've watched any of my other videos on hybrid and electric vehicles, you know that I like to take things apart farther than I'm supposed to, like that battery cell pack that we looked at. But these upper covers here on the battery are not supposed to be removed, but this is our car. I can do what I want to it. So we are going to remove it. There is a junction block that connects battery modules 2 and 3 to battery module 1. And it's just a battery bus bar, just a metal strip. We'll take a look at that here in just a moment. But there's another bus bar underneath this cover, and then we've got all of the parallel cell groups welded together and their bus bars that we can see underneath all of this. And then you'll also notice we have 1, 2, 3 electrical connections here. These are the electrical connections for the voltage sensing lines and the temperature sensors. There's a temperature sensor on each side of each battery section to let the battery energy control module and the hybrid powertrain control module number 2 know what is going on with the battery temperature, as far as the battery will get hot when it's discharging, it'll get hot when it's charging. We need to control the temperature of the coolant that goes through this battery by monitoring those temperatures and then either adding heat or removing heat from the coolant to keep the battery in an ideal range. Now let's take the covers off of the top of this battery here. And of course, when you take the cover of this battery off, not only do we have just the positive terminal right here and negative terminal exposed, but we'll have the top of every battery cell group and their junction bars exposed. So let me open that up right there. And let's take this other one off also. All right, what we can see here is from the battery positive terminal, which is right here, we have a cell group, just like that one that I showed you out of the early generation volt, the first generation volt. Except, remember, it has two plates, two battery cell plates welded together rather than three. And then we have these copper coated bus bars, or copper, that are welded between the negative terminal of the first cell group to the positive terminal of the next cell group. So negative, positive, just like flashlight batteries, you put negative, positive all the way in, and we just have a big serpentine back and forth, positive, negative, from that positive all the way down here to this negative, giving us, with 44 cell groups, 162.8 volts with 3.7 volts per cell group. So 3.7, then you add another 3.7 to it and you get 7.4, and so on. Now that's the nominal voltage, the expected normal voltage, but these have been fully charged. When I got this volt brand new, the battery was fully discharged down, well, it shows that it was discharged, but technically it's down in that 20% range, which we typically don't want to go below 20% or above 80%, and that's so that we can extend the life of the battery. These batteries don't like to be cycled fully dead to fully charged a lot of times, and so we can extend the life of the battery by never going fully dead or fully charged. So we've got these individual cell groups. Let's zoom in and take a look at one. Notice right here we can see one lithium-ion battery cell. I just bent the top of the, looks like that, I don't know if that's positive or negative, post piece of the battery cell sticking up, and then there's another one right below it. So there are two battery cells welded together per cell group on this second generation volt, but there were three on the first generation volt. And then you can see the copper bus bar connecting one cell group to the next cell group. Then if we move over to right there, we can see the bus bar. This is a bus bar, this metal piece right here, bus bar, that takes the negative terminal of battery module 3 and connects it to the positive terminal of battery module 2. And then it has its cell groups and continues on until we reach another bus bar where we take the negative terminal of battery module 2 and connect it to the positive terminal of battery module 1. And then all the way down on the end of the battery is our negative terminal, and this is the overall negative terminal for the entire volt battery, the 355.2 volts. So this is the negative terminal. So our three battery modules here are wired in series, just like the battery cells are wired in series. So battery module 1, here's the negative post, here's the positive post. Battery module 2, negative post, positive post, with a bus bar between them. Battery module 3, negative post, positive post. And then we put the next two battery sections in series with these to get the total 355.2 volts. Now, these three black electrical connectors here, they are voltage sensing lines so that the battery energy control module can come in and measure the individual cell voltages for each cell. So there's an electrical connection, and you'll notice that this white printed circuit board here has a circuit that comes over and is riveted right to one of those copper bus bars, and that's how it measures the voltage of that particular cell pack. And there's a rivet on each individual cell pack so that the electrical terminals down in this connector are connected to each individual cell pack. So now I'm going to put the battery cover back on battery modules 2 and 3. It just snaps into place. It's actually marked with a plus and a minus over here. And that'll give us a place to put our multimeter. The meter I'm using is a Fluke 87 Series 5 multimeter. I've got it set on DC volts. This is a Class 3 multimeter. I've got Class 3 probes here. They can be Class 2 or Class 3, depending on which direction you twist the probe tip. In this configuration, they're Class 3. In that configuration, it's Class 2. We're supposed to use Class 3 on these high voltage batteries. And I'm going to take a measurement of a cell pack battery voltage right on the cell pack itself. And then I'll show you a special tool that was developed for measuring these voltages to simulate what the computer does that monitors the entire battery. That's called the battery energy control module. We're on DC volts, and I'm just going to measure this very first cell pack voltage. Notice we're getting 4.016 volts. So it's a 3.7 volt lithium ion battery cell pack, or cell in parallel making a cell pack. But this one is fully charged, and it's up to 4.016 volts. And then if I move on down the line here, if I go to the next one, we double that, and there's, except I got my meter leads backwards. We double that 4 volts, and we're at 8. Whoops, over here, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48, 52, 56, 60, and then 64. So all of those battery cells or cell packs are in series with each other and just add together, just like flashlight batteries at 1.5 volts each. You put 2 of them together, you get 3 volts. Well, we just put 16 3.7 volt batteries together that were charged to 4 volts each. Now, let me get the special service tool that's made for this so that a service technician would not have to come in and take this cover off. Let me get the cover back on so we're a little more safe. Get the tool. Now, General Motors has a scan tool called the MDI-2 and some software called the Global Diagnostic System, where you can go in with the battery still installed in the vehicle and look at individual cell voltages. And there's a certain threshold of difference of voltage. I think it's 0.03 volts, 30 millivolts. If it's different by more than 30 millivolts, then there's a problem. But don't quote me on that voltage. I'll have to look it up. I'm pretty sure that's what I read though, but sometimes I mix things up. But anyway, if the voltage reads out of spec on the scan tool, then you can come in and check the battery voltages themselves. It could be that there's a poor connection on the electrical connector that plugs into the battery itself, like this one right here. Maybe the pin grip isn't right, so we'll plug that in, or simulating the harness that the scan tool would read the voltages with on the data list. And then it could be a bad connection. It could be that one of these bus bar nuts has corrosion on it, and this would cause a whole section of battery voltages to be low where another one would be high. But there's a pinout box here, and we take our multimeter with our positive and negative terminals and plug it in right here. So I'm going to have to switch the leads back to class 2 to stick them in these holes here. Just like that. And then we have 5 rotary knobs here. This one down to the bottom selects which battery group of cells we want to test, and then these other ones check the individual cells. So for battery module number 1 back here, I need to get the service information printout that tells me which switches to use for that section. Battery section 3 is where we are at. Battery section 3 is in the back here. And then battery module 1, and we want to test cells 1 through 16. Now, how do I know which cells are which? How come these aren't 1 through 16? You have to look in the wiring diagram, and I saw that in the wiring diagram, cell 1 is connected to the overall battery negative over here, and then 16 through 44 over here to the positive terminal of this battery section, which is not the positive terminal of the overall battery, because remember, they're in series. So for battery module 1, section 3, cell number 1, we want to be in switch position A, right down here, which we are, and then simply cells 1 through 16 are tested with switches A, B, C, and D. So for switch number 1, which we're in the number 1 position right now, so we're reading 4.014 volts on cell number 1. Now I'm going to switch to cell number 2, 4.015. Cell number 3, 4.013. Notice they're not exactly the same, but they're close. 4.016, 4.016, 4.016. Then we have to switch to B for cell number 7, 4.017, 17, 16, 15, 15, 16. So that takes care of 12 of the 16 cells. And then we switch to switch C here now for cell 13, which is 4.015, 4.015, 4.014, and 4.015. So we've just manually tested the individual cell voltages of 16 cell groups in battery module 1 of battery section 3. And yes, it's confusing. And this is only a 18 kilowatt hour battery. I've got a Chevrolet Bolt right here that I'm going to work on next semester, starting in January. And it's a 60 kilowatt hour battery, and it's going to have many, many more battery cells and sections. And I can't even imagine on like a Tesla, like a P100D, 100 is the kilowatt hour rating, and thousands of battery cells and trouble codes for each cell group, each cell section, each cell. There's a lot of trouble codes, and the diagnostics, it's overwhelming at first, but when you realize that if you can understand what's going on with just one cell and then multiply that by however many cells there are, cell groups, like 96 on this one, then it's not a big deal. This battery has 7 battery modules. There are 10 in the Chevrolet Bolt over there. Okay, so the other 2 battery sections, section 2 and section 1, are just like this except fewer cells. We don't need to, in this video anyway, check the individual cell voltages of the rest of these because this is just a demonstration of how to do it. If I was performing actual diagnostics on a particular cell or cell group, then I would do that. This entire cell section has to be replaced as one unit. There is a big long set of 4 bolts that goes all the way through here, and don't ever get tempted to undo that because this thing spreads out. Just that little section that I bought off of eBay, that little thin section, when I took the bolts out of it, and that was 1 kilowatt hour, it spread out really wide. I can't even imagine what it would do on one of these. You'd have a difficult time ever getting it back together and not having it leak. So never ever, even I, who takes apart things he's not supposed to, didn't dare take apart one of these. Just because of the cost of how much, if I screwed it up, which I probably would, it would cost to replace it. We barely could get the money to buy the vehicle, let alone thousands and thousands of dollars for me screwing up a battery pack. So, all right, so the next thing on the list then is to put the other 2 battery sections on the battery tray here. Okay, we are ready to begin the middle battery section, section 2, installation. Okay, I've got all 3 battery sections, sections 1, 2, and 3, installed, properly secured with the retainers to the battery tray itself. Now the next steps are to connect the cooling passages. So battery section 1 has these cooling hoses that need to connect from section 1 to section 2, and there's one on each side. These little hose clamps right here have a specification of 18 inch-pounds of torque to tighten them up. little plastic fittings. And then in the back behind section 2 and between section 2 and section 3 we have 2 more hoses that need to connect right there, and for the inlet and the outlet, and they have the same torque spec for those. So I will connect those and get those torqued next. Okay, here on the front of the battery there's a battery bracket that slides back towards the front section 1 of the battery, and we slide it back as far as we can and tighten down the nuts on the studs to the same 80 inch-pounds that we held the battery retainers with. All of the batteries are sitting on little rubber strips, and then these retainers have rubber strips under them, so all 3 battery sections are squished in between these little rubber type pads. I don't know what they're really made of, but it looks like black rubber. But I'm sure this here in the front is intended to keep this front module here from moving at all during panic stops or an accident or anything like that. I have a hard time believing that any of them would move anyway, given the retainers and the hold down rubber pieces there. And then on the very front here we have the battery tray front brace, and this is what the big contactor assembly that we saw underneath the front of the battery pack under the vehicle slides onto, and we have all the contactors and relays and heaters and other things that we'll look at here in a little while in this video. But it has a bracket that needs to be bolted down as well to the same 80 inch-pounds of torque as the rest of the bolts on the retainers. Okay, next I'm going to connect the coolant hoses and torque them to specification. Okay, the regular electronic torque wrench I have does not go low enough for the hose clamps. This only goes down to 24 inch-pounds, which is 2 foot-pounds, and that's too tight. So I have to move to a dial-style torque wrench that I use for setting up the rotational torque on pinion bearings, and this goes from 0 to 30 inch-pounds, and we're looking for 18 on these hose clamps. I know some of you might be rolling your eyes thinking, why is he using a torque wrench on a hose clamp? Well, it's so much work to get this out of the vehicle that I don't want to under tighten or over tighten this to where it causes a leak. If it causes a leak, then at bare minimum you got to take it back out and fix it. At worst case scenario, that leak could build up inside and eventually cause a short circuit, which we do not want. It could also cause the battery to overheat, because as the coolant level goes down from leaking inside the battery, there's not enough coolant to go through the coolant plates to cool the battery. So it's a very dangerous thing, and so we need to be as precise as we can when we're putting something back together as serious as this. And we should anyway, but I know sometimes we take shortcuts, but you cannot do that on this battery or any battery. By the way, there is a pressure tester adapter to hook to the front of the battery that we will do before we put it back in the vehicle to make sure that we don't have any leaks. But still, with things heating up and cooling down over time, vibrations and so on, we want to make sure that everything's as tight as it should be to prevent leaks. Okay, at this point, we've assembled everything we can as far as battery modules and cells and sections, and now we're ready to put the wiring on. There are 3 sets of wire harnesses for this battery. There's the low voltage set, the 12 to 14 volt circuits. There are the high voltage monitoring circuits for the individual cell groups, and then we have the big heavy battery cables themselves for the positive side and the negative side and the series connections between the batteries. We have to take this positive post back here and connect it to the negative post of this battery, and then we take this positive post and connect it to the negative post of this battery, and then the overall battery positive is on the front of section 1. And then there's more electronics and electrical connections to connect to the outside portion of the battery. We don't want high voltage available outside the battery when the power to the vehicle is off, or when there's any type of a service problem, check engine light, or any time an airbag has gone off, a collision, anything like that. We want to shut off the power from the battery. So there are these parts called contactors that open and close to control that, and those are here on the front of the battery that we still need to install, and we need to look at how those work and all the parts involved with that. All right, there's one more piece on the battery I forgot. It's an electronic component that we need to look at, and it's the temperature sensor right here on the end of the battery module, or the battery section. There's a temperature sensor on each side of each battery section, so there are 6 temperature sensors, or thermistors as they're called. This particular one here is battery cell thermistor number 2 is its official name. As you can see, it has a 2-wire electrical connection right here, and then it just snaps into the end cap over here. There's this little white plastic nub sticking up, and to release the temperature sensor, we just pry up on that nub and turn the sensor sideways 90 degrees, and there is our temperature sensor. Just the tip of that little silver tip right there is the temperature sensor. And so that actually reaches in and touches the battery cell itself, one of those cells that we looked at. So if you had to replace one of these, you would just put it back in the hole and turn it 90 degrees and lock it in place. And then there's a little wire clip up on the top here, and a little plastic plug to hold it in place, just like that. So we have 6 of those temperature sensors, and the battery energy control module, that's a computer that's going to sit right here in a few minutes, is the one that watches those thermistors and reports the temperature to the hybrid powertrain control module number 2 up underneath the driver's seat. Okay, so the next thing we're going to put on the battery is the negative cable. The overall negative cable that goes from the battery negative terminal overall for the entire battery all the way up to the contactors that we don't have installed yet, but we'll have the wire here ready to install. So let's get this put here on the battery. There are some channels here on the side of the battery for the battery cable. Oh, looks like I've got one more thermistor to plug in over here. So, battery negative cable. We have an eyelet here that goes from the negative terminal right there all the way down to the front of the battery here. Make sure we don't have any twists. Everything down in the clips where they go. Just like that. Okay, now of course we have a nut to go on that stud there. The torque on these battery studs, or nuts on the studs, is the same 80 inch-pounds that we use to hold the battery retainers down. But this is such an important connection that in the service information they tell us these need to be clean and dry. You can't have any oil, grease, antifreeze, anything on them. And then you check the torque twice. It's such a critical torque that you torque it twice. So let me get the torque wrench. Got it set to 80. On these electronic torque wrenches, if you watch the digital readout rather than just waiting for it to click, you can hit 80 right on the mark. If you wait for it to beep or vibrate at you, you could have passed it. And we're shooting right for 80. 49, 58, 60, 70, 77. There's 80. 79.7 is what I got to right there. So let's do it again. 79.2 right there. Let me see if I can get it right to 80. Nope, a little too far, 81. So once it's too far, it's too far, and loosening it up isn't going to help, because if you over torque something, you can stretch the stud, you can smash whatever you're torquing. So it's probably a little bit better to be just slightly under than slightly over, but I'm sure there's a plus or minus specification there somewhere. But I have not seen it. Okay, so we've got the negative cable on. That's an easy one. But for the positive cable really is just this little tiny short thing, and it goes from this terminal right here just over to the contactors. But then we have a series cable that connects the positive terminal of battery section 2 to the negative terminal, battery section 1. And then we have another cable with our service disconnect in it that goes from the positive terminal of battery section 3 to the negative terminal of battery section 2. So we have to get those two cables installed next. All right, this is the series cable that goes between battery section 2 and battery section 3. Let me get the nuts out of here. It's going to start getting crowded down in there. By the way, there's a big dip right here for that structural support that we saw underneath the car. So now this is going to come in. It's got a couple of little clips. They're going to clip to these two little metal brackets right here. Going to sit in on top of that negative cable and slide down. Clip themselves in place just like that. And of course a nut. Working with these gloves is difficult. But it's essential. Let's see, let's do all the torquing at once. Here's our positive cable, and it's going to go from our positive post up here to the contactors when we get those installed. Like that. And then this is the last series cable that connects section 3, the back section, to section 2. Now normally this would just be a piece of wire, but we have a service plug here that physically disconnects these two wires. So this is an open circuit. When I bolt this up here, there will be no electrical current possibility going through here until I put in the service plug that then connects these two circuits back together. So let's get it over here. Okay, so we've got 1, 2, 3, 4, 5 more nuts to make sure that they're torqued properly. Let me hurry up and do those. Okay, here on the front of the battery we have the positive terminal for the entire battery and the negative terminal of the entire battery. And some of you may be concerned that they're so close together. But remember, the service plug is removed, so there is no connection between this negative cable that doesn't connect to anything except that back battery section, section 3's negative cable, which is opened by the service plug there in the middle. So if I take a multimeter here on DC volts and I go from the positive terminal here to battery negative, notice I have nothing, just induced voltages on the meter leads, 3 millivolts DC. There's no power here. I could touch these two together, it does nothing. And that's because the service plug is out, and that's what makes the service plug such an essential thing to remove, because it open circuits the final two wires that connect to the contactors that then can either apply it to the transaxle and the rest of the high voltage systems on the vehicle or not apply it. So the contactors are in control of connecting these two wires to the outside of the vehicle or outside of the battery or not. If that service plug is removed, then it doesn't matter if the contactors open or close, which they won't anyway, because there's a sensing circuit called the interlock circuit in the service plug that when it removes, the contactors automatically shut off, and it won't, they should automatically shut off and shouldn't have a voltage present at the front of the battery. And that's why when you do the system disabling procedure before you remove a battery, you take the key fob out of the vehicle to put all the computers asleep, you disconnect the 12-volt battery, which kills all the power that activates the contactors, and then you check to see if the contactors in fact are open, because you will not have any voltage on these two wires on the outside of the battery or the cable up on the transaxle itself. And if that's the case, then you're safe to come and just unplug everything, drain the coolant, and take the battery out of the vehicle, which is what we did. All right, now the next thing, so far we've put on two wire harnesses, the negative cable and the positive cable with its series connections going back to the positive terminal of every battery here, putting them in series, just like 3 big flashlight batteries. But the next harness is the voltage sensing and the temperature sensing harness. And there's a big warning in the service information saying, put that on last and plug it into the computer last, because the computer itself has balancing circuits in it that balance the voltage in between each cell group to try to make them all equal. And it receives its power from these batteries. Well, if you hooked up all the sensing circuits first, it would sense a different voltage on one battery module or battery section versus another one, because they're not connected together. The voltages would be wrong, and it could cause internal damage to the battery energy control module, the BECM, that sits on top of the section 2 battery there. So let me get the voltage sensing wire harness and we'll plug it in next. Okay, this monstrous harness is the voltage sensing harness, and it's orange like all the orange cables, even though they're little tiny wires, to remind you that they are still connected to high voltage circuits, and there's a definite possibility of being injured if you don't know what you're doing and not following the instructions. So we've got all these orange electrical connectors that connect to the voltage sensing points on top of each battery section that we've looked at already. We connected that pinout, voltage pinout tool to. There are individual little tiny black connectors here for the temperature sensors, and they are actually a low voltage sensor, even though it's in an orange harness. But notice the connector is black. It's not orange. And then we have a bunch of electrical connectors where it connects to the battery energy control module, the computer that monitors the condition of this battery and its temperature and everything else. And we have to get all that hooked up very last. So let's get this harness installed next. Okay, that was 13 electrical connectors with a whole bunch of these little pressed down locks to hold the harness in place. Proper routing of the harness to make sure it doesn't interfere with anything or rub on anything. Before I took this apart, I took a lot of pictures, which is a really good idea anytime you take anything apart. But I always have photographs to go back to if there's something that I can't remember how it went. Now, the last thing we need to install here is the bracket to hold the battery energy control module, and then install the battery energy control module. So let's do that next. Okay, I've got the bracket for the BECM installed, the battery energy control module. It has 8 electrical connectors, and they are not numbered sequentially like you would think they would be. We have connector 7, X7, and then 1, 2, 3, 4, 5, 6, 8. Who thinks of these things? Anyway, all of these are voltage sensing connection circuits except for 2 of them. Connector 8 and connector 7. Connector 7 connects to our temperature sensors and our current sensor in the contactor assembly. And then connector 8 has our communication lines, the CAN line, the GM LAN line, the 12-volt power and ground, the switched ignition power, the wake-up signal to wake the computer up, and so on that. So low voltage circuits are these 2 connectors here, and then the high voltage circuits are those 6 right there. So let me get that plugged in here next. Okay, that's quite a process. Getting all those connected up, a lot of parts, a lot of connections, a lot of terminal position assurance clips and connector position assurance clips, and hold down brackets and cables, and you got to be careful on every one of them to make sure you don't damage anything. All right, the very last thing that goes on this battery tray before we put the cover on and before we pressure test the battery is the big contactor relay assembly that goes in the front here. So let's go over to my workbench. I've got that totally disassembled, and we need to take a look at it, how it works, what parts are there, and then come and hook it up to the battery tray as well. Okay, here at the workbench I have the front of the battery assembly. General Motors calls this the battery relay assembly. But it has a lot more in it than relays. And so let's take a look at the pieces involved here. We have a high voltage 2-terminal electrical connection that goes between the two big heavy wires, the orange cables, from the transmission inverter to the battery itself. So this big heavy electrical connector right here is going to come in and bolt down right here in the front of this cover. And then we have 3 small electrical connectors right here that will come in and bolt in right here. And those 3 connectors are for those 3 wire harnesses we saw under the vehicle. We have one that goes to the heater core coolant heater, except it's not in the heater core, it's external. We have one for the electric air conditioning compressor, and one that goes to both the plug-in charger assembly module and the accessory power module to run the 12-volt system on the rest of the car. So we've got those 2 electrical connectors. Let me get those bolted down. Okay, I've got those connectors attached to the front housing here. An interesting thing about this electrical connector I want to show you, the big high voltage one here. If you look closely there, you can see there's some plastic sleeves that actually cover the electrical terminals. If I push in real hard on them, it exposes the metal terminal. And so it's a safety sleeve that gets pulled out and covers that terminal when you unplug the big electrical connector underneath the vehicle. So it's a neat idea. It's a safety component. On the opposite side, we have 2 terminals here that are going to connect to the relay center itself here, and we'll look at that in just a minute. Then we have a low voltage wire harness that we need to start connecting. Right here is an interlock circuit, because this hole right here is where we access 3 high voltage fuses that protect the circuits connected to these 3 electrical connectors right here. And if we take the cover off to access those fuses, there's an interlock circuit in there, 2-terminal circuit, that will open up the contactors if they were closed, which they shouldn't have been anyway, but it's just a safety related item. Lots of safety here. So I've got a low voltage harness, black cables here, and let's connect it to the bracket here next. All right, and what that did is it gave us an electrical terminal or connector here for this cover to plug into. Then we have a gray electrical connector here. It's connector 357. It has CAN data communication. It's where the HPCM, the hybrid powertrain control module number 2, controls the relays, the pre-charge contactor, and the interlock circuits. The positive contactor, the pre-charge contactor, the negative contactor. and the charging contactor. Over here we have connector 357, this black one, and it has wires, I'm sorry, 358, for the GM LAN, which is a communication line, power, ground, ignition switch, wake up, and control of the auxiliary heater unit. So there's a heater that heats the coolant that goes into the battery, and we'll look at that here in just a moment. But let's get these electrical connectors held down with their proper screws here. All right, we've got those bolted down. On the back of the relay center here, we still have more harness to connect. This eventually goes over and on top of the battery connects to the battery energy control module, the BECM. And then we have a couple other electrical connectors here for the current sensor, for a temperature sensor, and for the battery coolant heater. And then a couple of ground circuits. These are low voltage grounds for the 12 to 14 volt circuitry that's in the battery for the BECM and for the rest of the vehicle also. So we have low voltage power and ground, and then high voltage power and ground. The high voltage power and ground, by the way, is totally isolated from the rest of the vehicle, or at least it's supposed to be totally isolated. There are trouble codes and diagnostics for loss of isolation, and loss of isolation means that maybe one of the high voltage circuits is contacting a low voltage power or ground, most likely ground, somewhere, but those can be diagnosed, and that a loss of isolation will shut down the vehicle immediately anyway. Okay, the next thing to go on is the coolant heater. So let's take a look at the coolant heater for a moment. This is the coolant heater, and you'll notice it has a big electric heater coil right there. It has a resistance of about 72 ohms, and so if you take the 355.2 volt battery voltage divided by the 72 ohms, you end up with about 5.5 amps of current. If you multiply that by the 355.2 volts, it's about 1750 watts of power that this heater will use to heat the coolant going into the battery if it's too cold. The battery doesn't operate properly if it's too cold, so we have to use some of the battery's own power to heat the coolant going through it, to warm it up so that it can have enough power to operate properly, or that enough temperature to operate properly and get you down the road. In the cold wintertime, your battery range can get cut in half in really cold weather. And of course, in hot weather, we don't need to heat the coolant, we need to cool it. And so there's a special air conditioning compressor evaporator heat exchanger called a chiller that the air conditioning compressor will actually run refrigerant through and absorb heat from the coolant and cool the battery down that way by removing heat from the battery. So this 1750 watt heater sits in a housing here. Let's get that bolted down. Okay, in this battery heater housing, there's a temperature sensor that plugs in right here. It has a couple of seals to keep coolant from leaking out of the sensor hole. So we've got some of the GM Dex Cool coolant as lubrication. There we go. Got the sensor down in, and then it has a clip that holds it in place. Just like that. So there's our temperature sensor. Then we have a fitting for the coolant pipes at the front of the battery to connect in through. So this is the coolant inlet right here, and we are going to put this fitting in here and line it up on the back with our coolant heater. So just like that, we've got the coolant fitting screwed in, the coolant heater on the back. I've got the ground wire in the wrong location. It needs to be over here. Okay, we are ready to tighten this cooling fitting and install the other cooling fitting right over here. And the torque on these is 33 foot-pounds with a 35 millimeter socket. Okay, we've got the heater installed, we've got the other cooler fitting. This is the inlet, this is the outlet. There are hoses that hook to the back that actually switch sides because the inlet side on the battery is actually over here and the outlet's over here. But for some reason they've done it this way here on this battery relay cover assembly. Okay, now we've got a temperature sensor connector right here for the coolant heater. Connector position assurance clip, and that's it. All right, now we've got a part that is not serviceable, but of course, as I usually try, I take things apart that I'm not supposed to take apart. This is supposed to be bolted to this housing here on the back, and the bolts that hold it in place have blue Loctite on, and they're very difficult to remove. You got to remove them very slowly with a ratchet to avoid breaking the bolt or stripping the threads out. But I wanted to open this up and see inside of this, and I did. I've got a picture right here I'll show you. And I just wanted to follow the wires to see what fed each fuse, where do these three electrical connectors get their power. Is this really the negative contactor and positive contactor, or positive and negative connections? We've got the pre-charge contactor, the pre-charge resistor, and the the plug-in charger contactor over here. We've got a fuse that goes here. We've got a current sensor that has high resolution and low resolution, or fine or coarse, fine and coarse as they call it in the service information. And then we have a controller for the heater itself. All of that just plugs into here, and every one of these pieces here that plug into this are serviceable, unlike the Toyotas that we've looked at in previous videos, and some of the, well, no, Hondas had serviceable parts. Ford and Toyota did not. You replace the entire hybrid battery junction block if a single contactor went bad, but not here. So anyway, I'm going to put this back on here now. If you look closely, you can see the two electrical terminals right there where the two big orange wires come in and connect, and they then go into the connect to the positive contactor and the negative contactor, because one of these is positive and one of them is negative. I believe the one on the top is positive, the one on the bottom is negative. Yes, it corresponds with the positions of the contactors. Okay, so let me get this plugged in. It was very difficult to remove. It took some terminal release tools and being very careful not to damage the terminals on those three smaller orange wires as I removed them. And then I've got to make sure that they all plug into the 3 electrical connectors properly on the front. It looks like it would be easier to take this connector back off the front, so let me hurry and do that. Three, okay. All 3 are through. Let's hurry up and get the bolts in. All right, we've got the equivalent of a bus bar circuit system inside of this plastic housing that makes connections between the 2 heavy wires coming in, the 3 smaller wires going out and back in, and all of the contactors, relays, and so on. So next, let's install the rest of these pieces. We have a current sensor right here that is serviceable. Measures current going through this little strap of wire coming from the battery positive terminal, and then goes through the sensor and then into the internal circuits here on this board. So we'll get that installed just like that. Then we've got a high voltage connection right here, little screw. We're going to torque it to the same 80 inch-pounds that we did the nut, like the positive terminal nut right here, when we go over to the battery and hook up the positive cable. So here is our positive cable connection and a cover for it. And here is our negative cable connection for the battery over there and our cover for it. And I'll torque these 3 bolts that hold down this plastic housing that I wasn't supposed to take off. Take it to the same 80 inch-pounds. Okay, the rest of the parts that are totally serviceable here, as I've mentioned, are the positive contactor. Now the job of the positive contactor is to connect the positive battery cable from that battery that we just put together to the big heavy positive cable that connects to the front outside of the battery. So that's what the positive contactor does. These will go bad over time. The more current you make them handle, the faster they will burn out, melt, destroy the contacts inside. So that just plugs in, and you can buy those and replace them. We've got the negative contactor right here, and it connects the negative cable from that battery we just put together to the negative high voltage cable on the outside of the battery. So we'll plug that in. Then we have a transistor module with a big heat sink. This high voltage transistor module controls the current going through the 1750 watt battery coolant heater. So let me plug that in with its connector position assurance clip and plug in the transistor, high power transistor that controls it. Just like that. Then we have a charging system contactor. When you plug in the charge cable to the volt to charge the battery when you get home or wherever you are, this contactor, along with the positive contactor and the negative contactor, have to close to allow the plug-in charger to feed the battery itself after the AC voltage that you're plugging in gets inverted to DC in the back of the car. It gets sent back up through these contactors and charges the battery back up. Now there's a 10 amp fuse here. It's 450 volt 10 amp fuse that protects the electrical circuit for the battery heater, and it plugs in right here. That's serviceable. If your heater shorted out, it'll probably blow that fuse also. We have an electrical connector here that interfaces with the outside HPCM2 to control all of these contactors and transistors. And then we have a pre-charge resistor. This is a 50 watt 70 ohm resistor, can handle a lot of heat. This pre-charge resistor is used with the pre-charge contactor. Here's the pre-charge contactor right here, to charge the big smoothing capacitor inside of the inverter on top of the transmission. And when it gets charged, the voltage on the negative terminal of that smoothing capacitor will be 0, which will be the same voltage as the negative contactor ground side, and we can close the negative contactor with no voltage differential, and it won't arc and destroy the contactor sooner than necessary. So we use the pre-charge contactor and the pre-charge resistor to save the negative contactor from getting destroyed by charging the smoothing capacitor in the inverter. The smoothing capacitor's job is to help smooth out the AC to DC conversion every time you decelerate or have regenerative braking on your vehicle as you slow down. All right, what else are we missing here? We've got the battery cover we got to install and the electrical connector on the front. The next thing to connect up will be our ground wires for the low voltage system here. Without them, the contactors wouldn't be able to work, the battery heater wouldn't work, the vehicle wouldn't move. So they pick up the ground off this aluminum housing here, and then these two ground wires pick up their ground off of the battery tray. There's two studs there that these connect to, and then the battery tray through the bolts where it bolts into the vehicle provides the rest of the ground. So let's torque these to the 80. Okay. And then we have two coolant hoses. One that goes from the return side of the inlet to the return side of the battery. Remember I told you they swap sides here, so let me put that down there. And of course it's got the hose clamp with the 19 inch-pounds of torque. Okay. Right there. And then another coolant line that goes from the back of the battery heater over to the inlet side of the battery, which is actually on the driver's side. These are called cooling manifold hoses. Right there. All right, so that completes the back of our relay assembly here. These part numbers here, if you look them up on Panasonic's website, they actually are, Panasonic actually does call them relays, but in the service information they call them contactors, and if you open them up, they would have two poles closing at the same time, like most contactors do, to handle high amounts of current. They're sealed, they're hermetically sealed, vacuum sealed. No oxygen can get in there. It's quite a bit more robust than just a relay that, say, a horn relay or a headlight relay or something like that. It is not the same thing. All right, then on the front, we need to put our orange electrical connector back on, and it has some locking little tangs that have to clip into place. There's 4 of them per electrical connector here, that had to be released when I took that apart, and that was a chore. They all snapped in place. Now I can screw that back down. There's no torque rating on these in the service information because you're not supposed to take them apart. So I'm just guessing. Tightening them by hand. They weren't very tight when I took them apart. All right, the very last piece to put together on this relay assembly here is the cover that covers up the 3 high voltage fuses that protect these 3 circuits here. Kind of a weird thing is we've got connector 4, 5, and 6 right here, but the fuses up here are ordered 5, 6, and 4, so they do not correspond directly with the connector order down below. So now we'll install the cover with the interlock circuit in it and the 4 screws that hold it in place. On the front of this cover it says danger, high voltage, 360 volts. Has a picture of a hand with the crossed out circle through it saying don't touch it. Has a picture of a service manual with a wrench on it telling you to look up service information, and it has a picture of a guy getting shocked, drawing of a guy getting shocked there to warn you that it's high voltage. This is all accessible underneath the vehicle. It's just wide open. I mean, it's fairly tight. You've got the cross member and stuff in the way here, but it's right there. You could stick your hand up in here underneath the vehicle and get to this. All right, this is done and ready to go on the vehicle, but there's one more final piece that we need to look at in this never-ending video on the volt battery, and that is the service plug. And I saved it for last because it's the last thing that we would install. The service plug has a high voltage interlock circuit. See those 2 little pins there? That's part of the interlock circuit. It has a resistor there. I measured that once, but now I forget what the resistor value was. Let me measure that real fast. 39 ohms, which is interesting because most interlock circuits don't have a resistor. It's just a short circuit. So this would tell the HPCM where the open was based on the voltage drop. So that plugs in right there. Then we have a 420 volt 350 amp fuse. Look at this monster. It's made by Bussmann. It's rated at 20,000 amps maximum before it finally melts, and of course that's in a couple of milliseconds before that would blow all the way open. The 350 amps that it's rated for there, it'll handle 350 amps. It's interesting if you looked up the part number of this fuse here, the EV30-350-TB, to see the rating on this, because it is a monster fast-acting fuse, but it will also handle a lot of current for a long period of time before it finally blows. But it's all relative to the amount of current also. All right, so this comes and just plugs straight in right here, and then there's a clip that goes over that holds it in place. Let me make sure I've got it lined up properly. Just like that. That keeps the fuse from falling out. And then we have the actual service plug cover that goes on the other side here, and it is going to rotate. There's 4 positions as you rotate and lift and rotate and lift this service plug to get it out of the socket on top of the battery there. which is right underneath the center console. Lift up your center console, pull out the console insert, and this will be there with instructions of how to remove it during service work. But do not remove this unless you're doing service work and have the 12-volt battery disconnected, because it will set a code that will prevent the vehicle from working again until a professional clears it. Like that. So we turn it this way, it'll lock. Turn it this way, it'll unlock. And then we turn the whole thing a little bit, and then we pull. The 4 positions are lock, unlock, and then we lift. As we lift, it disconnects the interlock circuit, and then as we pull even more, it disconnects the high voltage fuse. So this is, it's called, every part on a GM vehicle has every electrical part, mechanical part has a number. This is the S15 manual service disconnect plug for the volt battery. So that's all ready to go right there. All right, so we are ready to install the relay center and not install the service plug until we get it back in, until we put the battery back in the vehicle, which will be a different video. We're out of time. I'm out of time today. I'm going to bolt this up and go home, but we still need to pressure check the system, the cooling system, to make sure there's no leaks. We have to put the cover on and do a smoke check with the emissions test machine to make sure there's no air leaks to allow coolant in or dust in or anything like that that can contaminate the battery, and then put it back up in the vehicle and check for trouble codes and make sure everything works as it should. So that's going to have to be a future video. So let's go put this back on the battery tray and we'll call it quits. Okay, here we are back at the battery. Got my high voltage gloves back on, and we're ready to put the relay assembly here on the front of the battery tray. There's a battery tray front brace that this relay assembly slides into. It's got a couple of grooves right here and a notch right there that line up with that battery tray front brace. And then we have 2 ground wires that connect to a stud right here and a stud right here, a ground on each side. And then we have 2 coolant hoses that have quick connect fittings, no more hose clamps, to the front of battery module 1, or battery section 1, which is battery module 7. And then we've got a low voltage harness that we need to connect to the battery harness right here. So let's get this up on here. Make our quick connect fittings. Connections on the battery. Slide in. The relay assembly. Get our ground wires laid down there. We're not quite on the bracket properly here. Here we go. Okay. We're slid into place. So we'll lift up our positive and negative terminal covers where they connect to the relay center. Here we go. Looks like the nuts are still on there, so I need to take those off. There's our negative. So we'll take our negative cable here, put it right there, put the nut back on, just like that. And then our positive terminal, take that cable, put it on there, get the nut back on, and of course we'll double torque those to 80 inch-pounds. We'll put the nut down here on the ground stud for one of those 2 wires, the ground wires. Get it torqued to 80. And then there's a nut on the other side as well. And then we have our low voltage cable that will come up. So let's get these torqued first. 80.9, 80.7. And then the positive terminal up here. 80.7 and 79.4. Negative terminal 79.5 and 79.5. All right, we've got the other ground nut 81.9, 81.3. All right, now I can cover our negative terminal. I lost our positive terminal clip, or cover. So here's our positive terminal cover. And then we've got our low voltage harness. That's going to plug in next. All right, then we'll push our relay center all the way back. Make sure we don't have anything rubbing, interfering, loose, missing, and it looks good. All right, let's do one final review of the battery and this video. So here in the front of the battery, facing the front of the vehicle, we have the two wires that are the big heavy wires that go to the transaxle inverter that will connect right here at this connector. We have three smaller connections for the coolant heater module for the heater core, one for the air conditioning compressor, and a shared one between the plug-in battery charger and the 14-volt accessory power module, also known as a DC to DC converter. We have a coolant inlet and a coolant outlet for this liquid-cooled battery, and then we have low voltage connections right here for the control of the contactors, relays, heaters, and everything else, as well as communication with the battery energy control module, the computer inside of the battery. Under this cover right here, we have high voltage fuses to protect all three of these circuits right here. As we work our way around the battery, we can see now that the relay module with the contactors has a connection from the negative high voltage cable that comes all the way from the back corner right there of battery section 3, and the positive connection that comes from right here at the front of battery section number 1. We have coolant connectors here, coolant heater, current sensors, and so on. We have low voltage circuits, we have high voltage circuits, monitoring individual battery module cell groups. There are 96 cells in this battery at 3.7 volts each. They're all in series with each other, and that gives us 355.2 volts. Each cell group actually has two cells welded together in parallel on the second generation volt, and three cells welded in parallel on the first generation volt. As we move our way back, we can see the coolant plate hoses, the transfer for the coolant to go through. We've got the battery energy control module, the computer that monitors through all these orange wires on top of the battery, the individual battery cell group voltages and the temperature sensors that are on the end of each battery section. Right here, this round connector is where the service plug is actually going to plug in once it's up in the vehicle. But we are not going to plug that in until we get it back in the vehicle, because that would give us full live voltage here on these two terminals at the front of the battery, although there wouldn't be any voltage in the front because the contactors are still open. And then the back section here, we've got the negative terminal, temperature sensors, voltage monitoring sensors, wire harnesses going everywhere. And as I said, this is only an 18.1 kilowatt hour battery, unlike the 60 kilowatt hour battery that's in our Chevrolet Bolt right here that we will be looking at in a future video next spring. Okay, well, it's been a long day. That was a lot of work putting all this together. I got here at 8 o'clock this morning and it's 5:30 p.m. right now. It took that long to put all this together and get this video shot. But for me and my students, it's well worth it. There's a lot to learn, a lot to know here, and it takes the fear for me and my students out of working on the hybrid and electric vehicles with the high voltage systems. Knowing all the individual pieces, what they do, the safety precautions, all the safety mechanisms built into these are very impressive. And you'd have to really be doing something stupid to get yourself shocked or in trouble. As I said before, we will have more videos as we finish pressure testing the cooling system on this battery, put the cover on, smoke test it for leaks, and putting it back in the vehicle and making sure that everything is working like it should. But that's for a different day. So for now, thank you for watching. Have a good night.